Hello, and welcome back to yet another retro channel. About a year ago, not long after I started yet another retro channel, I decided I'd go ahead and take my lumps early and get one of the, shall we call it, rites of passage taken care of. And I started what I called my epic C64 Repairathon. I had 8 bread bins that I needed to repair, and I used my meager skills and eventually got them done, though some of the computers took more than one video to complete. It's been over a year now, as I've said, and I want to give my skills another try. So today I'm starting a new Commodore 64 Repairathon for 2024. This time I actually have 10 machines, so by those standards it's actually more epic than the first one, though I'm not going to call it that this time. And we're going to see if my skills have improved, if my logic is improved, if my troubleshooting methodology is improved, and if I can get these machines done quicker. I'm going to try to do at least 1, if not 2 machines per video until I have only 2 or 3 left, and then I think I'm going to do a live stream for the last few machines. So, that being said, let's get started. Alrighty, the first thing we need to do is to validate that our testing setup is going to work. So we need to check our audio and video connections, and we need to check specific test equipment, in this case the ZIF64, the ZIF board that I've been using. This board, in case you haven't seen it before, allows me to test individual ICs very easily, as it has 0 insertion force sockets for a lot of them, and I can just pop an IC out and pop a potentially bad IC in and see if it still works. So to do that, we're going to bring up the output here, and we've got the test harness in, but right now that's not going to be working. First we're going to run it through dead test, and then we're going to run it through the full diagnostics. So here is dead test. Alright, dead test is running. We'll spin through that until we get to the sound test, and then I'll let you hear the sound. Okay, that's dead test, and as you can see, the video is working well, and you can hear the audio is working well as well. So let's pop out our VersaCart here and switch over to the full diagnostics. Now the reason we do this, as I said, is to make sure that everything is still working, and what that does for us is it makes sure we're not chasing our tails. If we bring up one of the test machines and plug it in and turn it on and we get no image, if we haven't verified that our testing setup is good, that could be being caused by something in the wiring, the retro tank, the image capture, anything like that. If we verify first that everything's working, then we don't have to worry about chasing our tails like that. Here is standard diagnostics. I actually think everything sounded about 99% correct, but I think I'm going to have to say that I'm starting to lose this SID. It's just barely sounding a slight bit wrong. So anyway, that verifies that our testing setup is in good shape and ready to go. And just one final thing that we've always got to do. Alright, so that verifies that our testing setup is in good shape. So now we can start with actual testing. So here is machine 1, a standard bread bin. It's a little dirty. I don't think it's too badly yellowed though, so this one may not need to go through a retro bright stage. Hook up audio visual and hook up my bench power supply. Now some of these have notes on them saying what the symptoms were. This one does not. So we're just going to check it out together. Go back over to the output and turn the machine on. We do get the power LED, but I'm getting nothing, no signal at all on the screen. That's a bad sign. That could very well indicate a dead vic-ii. So we're gonna have to open her up and see what's going on. We do have all the screws and all the feet, which is a good sign. Good crack from the clasps, or the clips. And oh boy, this was unexpected. I fully expected most of these to be 250407 boards, but as you can see here, we actually have a 250425. So we have the additional heat shield, RF shield, and heat sink shield. And a lot of socketed chips, which is a good thing. Okay, set that to the side. We will be reinstalling that because, like I said, it does provide some small amount of heat sinking. Now, the first thing we need to check will be voltages. Let us see what we're getting with voltages. Okay, first I'm going to check the two voltages on the regulators. These feed the vic-ii and the SID. They come from the 9 volts from the power supply. So this one should be the 5 volt. And it is. And this one should be the 12 volt. And it is. Okay. So the voltages getting to the VIC are good. Let's check our voltages. Our 5 volts at the user port is low, reading 4.4. So we probably got a short somewhere on the board. Now let's check the AC up there. .1, that's fine. So we still have no video out. Our voltages are good. Check for reset. Okay, reset looks good. Let's look at the clock input. Well, that's it's a good solid 1.02 megahertz clock, so the VIC-2 is at least producing a clock signal. It's just not producing a video output. Okay. Time to bring back the ZIF machine. First we will pull out the VIC-2. Really did not want to see bad VIC-2s. I don't actually have any of them at the moment. I do have 2 on order. If it turns out to be a VIC-2 issue, I'll have to borrow one from another board. Make sure the VIC-2 is still working, or make sure the ZIF machine is still working, and it is. So remove the good working VIC-2 and put in the in question VIC-2. I really hope this works. Nope. We have a dead VIC-2. So we will try this board with the VIC-2 from the ZIF machine. There we go. The problem was the VIC-2. Let's run it through the diagnostics to make sure. This will, of course, tell us if there's anything wrong beyond just the VIC-2. CIA timers are good. RAM seems to be testing good. PLA is good. All right. Everything was good but the VIC-2. So, well, that's one machine down. We know what the problem is. We just need to replace the VIC-2. Okay. I need to put a note. So, that one just needs cleaned up and a new VIC-2. So, let's take a look at machine number 2. Now, this one is missing an F1 key. I can replace that, not a problem. It's dirty. Again, doesn't look too yellowed, so I think I might get away without retro-brighting this. Use this adapter here, the 5-pin video port, so it's definitely an older board. it's taped in the front, I'm guessing that means it's missing its screws. Yeah, I can replace those too. Not a big deal. But let's see if we get anything out of it. Ooh, no power light. So, only a very small draw on the power supply, 0.29 amps. So, something's definitely wrong in here. All right, let's get this one opened up. Again, not too much difficulty, just some Scotch tape, cello tape for you Brits out there. Ooh, I'm gonna have to do a little more work to get that off, so for the meantime, let's just use a screwdriver to slip through it. Oh, well, there's your answer. This one is missing all of its chips. We're going to need a CPU. What is this board? Wow, this is one of the old ones, the KU boards, I think. So we're missing a CPU, SID and PLA. I believe that's kernel and character ROMs and CIAs plus the vic-ii. So we know what the issue is here. Just put it back together. Call it missing main ICs and move on to the next one. Hopefully we don't have too many of those. I want to stop right here for a moment and ask you guys to, if you're enjoying this video, go ahead and give it a thumbs up. And if you haven't already, please subscribe to the channel. That really helps me out. Thank you very much. All right, number 3 does have its screws. It has THS 8183 on it. Rochwall, I can't even tell what that says for sure. Rochwall or something along those lines written on the back of it. So we'll give this one a shot. Okay. Power LED is forced through there, in there wrong. I'll have to fix that. All right, let's see. We're getting something. We're getting a black screen. Okay. So we are dirty. We'll need to clean up. Let us see, shall we, what the dead test has to say. Brown screen. Okay. I'm not sure what causes that. All right, let's get her opened up. Another 425. Now that's where we didn't get the LED. It was disconnected, and so is the keyboard. Well, we'd have some stickers. They were wondering. Oh dear. This is a mistake that I've made. Whoever repaired this before made the same mistake. That's a SID chip. This indeed. That's the 906.114-01 or PLA chip. So we had the PLA in the SID socket, and we had the SID in the PLA socket. Well, what do you know? I guess we need to test these and see if they're any good. So, back to the ZIF machine. And we will test the PLA first, since those are so notorious for being bad. Did we get anything with this PLA? Black screen. Okay. Just to be sure, we will reseat it. Black screen. All right. So our PLA is bad. Is our SID destroyed? Let's put our real PLA back in. And swap out the SID. This is set to dead test, but we'll get a sound test out of it. There are 2 more chips on this board that he's questioning whether or not they're good. So we'll test them while we have the ZIF board up here. It's the VIC-ii and the CPU itself. I did hear a bit of glitching, so that SID is marginal. Okay, now let's check the VIC-ii. Okay, our VIC-ii is good. And our CPU. And the CPU is also good. So, let's reseat our VIC-ii, our CPU, and for now, our marginal SID. And again, the PLA goes here, the SID goes here. You always know, because the VIC-ii always points to the PLA. So in the 250407, the VIC-ii is situated this way, pointing up, so the PLA is up here. In this case, our SID goes up here. And we need a replacement PLA. I have those. I honestly forget whether this is Plankton or PL Advanced. It's one of the two, but it should do the job. Alright, there's our new PLA. Now let's see what this board does. Okay, we've still got other problems. Either that or that PLA's not doing the job. I'll tell you what. Let's go for a PLA that we know for sure is working. I'll pull the one out of the ZIF board. Alright, let's try that. Nope, we've definitely still got other problems. Okay, let's use this PLA. So the PLA. Okay. Time to start looking at some signals. We'll look at the clock first. Oops. Oh. 1.02 megahertz on the clock, that's good. And we'll look at reset. Should stay low for a moment and then go high when I turn it on. Now. And reset's good. Let's just for safety's sake. So let's check some voltages. This should be 5 volts. And it is. And this should be 12 volts. Ooh. Hope I did not just pop. That's 12 volts. So we're good. And there we go. The 5 volts at the user port is a little low at 4.62, so we could have a short. And the AC voltage at the user port, 9.81, that's fine. Okay, so the next thing I'm going to do, one by one, I'm going to start pulling these chips since they're socketed. The dead test does not need the ROMs or the CIAs or even the SID to operate. So we know the SID is good. I'm going to go ahead and pull it first, just to get it out of the way, make sure it's not causing anything, which it shouldn't be since it worked marginally well in the ZIF machine. And we will start by pulling, I believe this was the character ROM, I always get them mixed up. So without the character ROM, does the dead test do anything? Yes, we get flashing. So we might have a bad character ROM and a bad RAM. 1, 2, 3. So it's 3 flashes. I need to look that up. Okay, I just realized I didn't test with the dead test with the ROM in. So with the ROM in, I'm getting the same 3 flashes. Now, 3 flashes, according to the dead test diagnostics manual, is U11. U11 is this chip, which is already in a socket. So let's simply see if U11 does anything when I change it. This is a previously tested and known good 4164 DRAM. Okay, what do we get now? Now we get one flash, which is U12, which is the other socketed DRAM. So let's pop that out and grab another one. The ones I'm pulling out are Okies. Okay, what does it do with that chip in there? Well, that's an improvement. No more flashes. But, ugh. Okay. I wonder if that's the problem. No, that's not the problem, but that's not good. PLA, the socket for the PLA doesn't like these turned pins. So let me see if I can do something about that. I think we've got an issue with the PLA socket. So I'm going to have to change it. Okay, let's get the PLA socket out. I'm going to add a little flux to hopefully make it a little easier. Well, that was almost too easy. Get a replacement. I'm going to actually use one of the milled pins since that PLA has the milled pins. Grab some Smurf poo, as I've recently heard this stuff called. Blue tack. Add a little more flux. Tack in the corners. Make sure we're flush to the board. And then solder in the rest of the pins. Put away the Smurf poo. There we go. That's more solid. Now let's see where we are. Alright. Garbage. Alright, now, as I said, with the dead test cartridge, you only need the CPU, the PLA, and the VIC-ii. These other chips don't need to be in there. So, to see which one might be causing the problem, or if one might be causing the problem, I'm going to remove them one at a time. Nope. Okay. So, now we need to start looking at the small logic chips. And we do have two 7708 MOS chips. We have actually 4 MOS branded chips. These are going to be our next suspects, because the Moss branded chips tend to go bad. Unfortunately, none of them are socketed. We're going to have to start scoping some signals to see if we can figure this out. What I'm going to do first, though, I'm going to bring this up, and I am going to look at the pictorial fault guide and see if anything stands out. Actually, let's take the diagnostics out. Okay, folks, that screenshot on the left in the pictorial fault guide looks an awful lot like what we've got going here. And that is telling me that it is U13. U13 is this little Moss logic chip right here. And that is... okay, that's going to be a 74 LS257. And we're going to pull that chip, put it in a socket, and see about replacing it. Okay, here's our new 74 LS257. And let's put it in and see what happens. Diag cart back in. Power and video. And what do we get? Still the same thing. Yep. Okay. So it's a Moss chip, it's staying out. I might test it later to see if it's still good, keep as a spare in case of emergencies, but since these are both the same thing, I'm going to try the other one. Another fresh new 257. And we'll see what happens this time. Actually, let's just do it without the diag cartridge. It'll be quicker. Anything new? Yep, there it is. Okay. Time to put it through its paces. I think we got it fixed. Okay, it's passing the dead test. So let's switch over to the regular diagnostics with the harness. And see what we get. Okay, we're seeing control port bad and 6581 bad because it's not in the board. So let's fix that with an arm SID. Alrighty then, we have another repaired board. Number 3. And that time it was a PLA, a SID, 2 memory chips, and 74 LS257. And we also replaced this one. Probably didn't need to, but it was a MOS chip, so it makes sense to replace it. That does leave 2 MOS chips on the board. I'm not going to change them. They're obviously working at the moment. And everything else is good. So it just needs cleaned up now. Well, that's going to do it for part 1 of the Repairathon. We got 3 machines done today. Okay, I admit one I didn't do anything to because, well, it had all of its chips plundered. So that one may or may not ever work again. Depends on if I have some extra chips around that I can rebuild it with. But the other 2 are, well, one is in fully working order, and the second one just needs a vic-ii chip, which I do have a couple of those coming, so we'll see if we can have that one working at the end. And stay tuned for the next one. We'll get through at least a couple more of those machines, and that'll do it for today. So if you enjoyed the video, smash that like button. I know everybody says that. If you didn't, you know what to do there too. Leave me a comment in the comment section below. I love interacting with you guys, so please go ahead and even if it's just to say hi, I appreciate you guys commenting, and I really do enjoy that. If you haven't already, please subscribe to the channel. All of this helps out getting my channel out to more folks. The more you like them, the more you comment on them, the more you subscribe, the more folks YouTube will push it out to. Share the video out to your social media and your friends. And I want to thank all my supporters. If you too would like to be a supporter, there are a few ways you can do that. First, you can become a patron on patreon.com. That link will be in the description below. You can also go to Ko-Fi and donate there. Or you can click the join button, which is down here somewhere, and join as a channel member. All those are ways that you can support the channel if you want to. You don't have to, but if you want to. And reach out to me through my Discord or my Facebook group, and I think that'll about do it for the day. So, everybody stay safe and well. Have a great week, and we'll catch you in the next one. Bye.